Place value is an important concept that we learn about when we're young and then partially forget about as we get older. And place value is intimately tied with the number system that we use. We use the decimal system base 10, but it's not by any means the only number system around. Computers, for instance, use binary, which is base 2, and they also use hexadecimal, which is base 16. And I'll explain really what that base means in a second. So place value, again, just refers to the fact that we use 10 digits, and depending on their place, they represent different things. So for instance, 321 or 321 really represents 3 times 100 plus 2 times 10 plus 1. And having place value really makes arithmetic a lot easier to do. If you ever learned Roman numerals, you know that adding and subtracting them is not very easy just because they don't use place value. Now, if you look at what each of these digits represents, the hundreds, tens, and the units or ones, 100, 10, and 1, these are each powers of 10, and that's why we say that we are base 10. We only use base 10 for no good reason other than the fact that we have 10 fingers. So there are certainly lots of other bases we could use. If you use base 2, you call it binary. So 100 can be written as 10 squared. 10 can be written as 10 to the power of 1. 1 can be written as 10 to the power of 0. They're all powers of 10. And if you're not sure about exponents, you can see some of the later lessons on exponents. Now, what happens with place value when we go to the right of a decimal? So we've already seen that the 321 represents hundreds, tens, and units. So hundreds, again, is 10 squared. Tens, 10 to the power of 1. Units, 10 to the power of 0. So the exponents are going down. 2, 1, 0. If we go down another one, we get to -1, and then down another one, we get to -2. So again, they're all powers of 10. The digit to the right of the decimal is the tenths unit, and the digit to the right of that is the hundredths unit, and the next one after that would be the thousands unit. So this number really represents 3 times 100 plus 2 times 10 plus 1 times 1 plus 4 times 1/10, which you can write as 4 tenths, plus 5 times 100th, which you could write as 5 100ths. So let's just take a closer look at one of these decimal numbers, 0.67. So this is the tenths digit, and this is the 100ths digit. So this number really represents 6 over 10 plus 7 over 100. And if you remember how to add fractions that have different denominators, first thing we need to do is create a common denominator. We can create a denominator of 100 by multiplying the 6 over 10 by 10 over 10. This gives us 60 over 100 plus 7 over 100. Now that we have the same denominator, we can just add the numerators and get 67 over 100. And in fact, when you first learned 0.67, your teacher may have made you say it out loud or write it as 67 hundredths. And really, that's what it is. So these decimal numbers are really just another way of writing numbers that are fractions, but they're very specific fractions that have denominators that are powers of 10. Now, not all fractions are going to convert nicely into denominators that are powers of 10, and that's why some decimals have repeating decimals. They go on forever if the denominator is not easily divisible by 10. Let's take a look at 2.89, a number that is bigger than 1, just to see how to handle that. So this number is, again, the 2 is the ones digit, the 8 is the tenths digit, and the 9 is the hundredths digit. So this is really 2 times 1 plus 8 tenths plus 9 100ths. And if we want to create a common denominator here, we can multiply the 8 tenths by 10 over 10. That gives us a denominator of 100. With the integer 2, anytime you want to create a common denominator, it's pretty easy. Just ask yourself, what is the denominator? It's 100 in this case. So multiply by 100 over 100. And you end up with 200 over 100 plus 80 over 100 plus 9 over 100. And you can write that as 289 over 100.